Okay, so in this lesson, we want to find the distance between 2 points in a coordinate plane, and you want to eventually use the distance formula. So the purpose of this lesson is to use the distance formula, okay? So use the distance formula. Now the difference formula, the distance formula says this, that if you have 2 points in a plane, so the distance between the 2 points, and I'm going to call this x1, y1. So this is my first point. The subscript represents the first point. So this is the x coordinate of the first point. This is the y coordinate of the first point. And let's say the second point, we're going to denote it as x2 comma y2. So the x coordinate of the second point, the y coordinate of the second point. Then the distance, so the distance between the 2 points, these 2 points is, and here's the distance formula. So the distance is the square root of, and you're going to see where that comes from in a little while, okay? But just write this down for right now. So it's going to be the square root of, and basically what's going to happen is you're going to subtract your x coordinates from each other. So you're going to say x2 minus x1, whatever that is, you're going to square it, plus, and then you're going to do the same thing with the y coordinates. You're going to say y2 minus y1 squared. Okay? So you subtract the x coordinates from each other and you square. Subtract the y coordinates from each other and you square it, and then you add them up. So that's the distance formula. But then what I want you to do, though, is not just memorize this. I want you to notice where this comes from. So it's important to understand, well, where did this come from? Well, first of all, you have to remember Pythagorean's theorem. So remember when you did Pythagorean's theorem in a previous course, and so you basically had these 2 points in a coordinate plane, and you want to find the distance. And so remember Pythagorean's theorem says this, that if you have a right triangle, remember you're dealing with a right triangle, okay? And if this leg right here, these are your legs, and the side opposite the right angle is the hypotenuse. It said that these legs and the hypotenuse we labeled C, it says that if I square each leg and add them up, that's going to equal the hypotenuse squared. So a squared plus b squared equals c squared. That was Pythagorean's theorem. I can use Pythagorean's theorem in this situation here. Okay? Now, they want you to use the distance formula, but to derive the distance formula, let's review how to do this using Pythagorean's theorem. So if I have the point 5, 8 and the point 1, 2, okay, 1, 2, 5, 8, if I have the point 5, 8 and 1, 2, and I will find the distance between those 2 points, I'm going to go ahead and draw a right triangle, just like this, okay, just like this. All right, so what I did, so I drew a right triangle. I want you to tell me what this point right here is. So do y'all agree that this point right here is 5, 2, right? 5, 2. Y'all agree with that, correct? 5, 2, okay? And then Pythagorean's theorem says, if I'm going to use Pythagorean's theorem, if I'm going to find this distance here, then I first of all have to find this horizontal distance and then this vertical distance, okay? So let's talk about this horizontal distance. So the grids are numbered here. So do y'all see it's easy to actually number off the number of units? So I start here, I go 1, 2, 3, 4, right? Okay. But but you really don't want to do that. I want you to use those coordinates. So rather than saying 1, 2, 3, 4, I want you to look at the x coordinates. What can I do to those x coordinates? Because remember, this is horizontal, it's parallel to the x-axis. What can I do to those x coordinates to get 4? I have the x coordinate 5, I have the x coordinate 1. What can I do to it? I can subtract. Now remember, when we're talking about distance, we need to make sure it's positive. So if you say 1 minus 5, that's negative, right? If you say 5 minus 1, that's positive. So it doesn't matter what order you use. Let's just go ahead and use absolute value to make sure it's going to be positive. So do y'all agree that distance is the absolute value of 5 minus 1, which is 4? Y'all agree? the absolute value of 4, which is 4. Okay, so the point here is this. The point here is that to find this horizontal distance, you're going to subtract the x coordinates. So keep that in mind. To find this vertical distance, what do you think you're going to do? Well, let's count first. 1, 2, 3, 4, 5, 6. How can I get 6 from those y coordinates? Here's 8, here's 2. What can I do? Subtract. So this, again, it doesn't matter what order you do, you can subtract. So if you say, I'm going to subtract 2 minus 8, I've got to take the absolute value, right? Because 2 minus 8 is a negative 6, and I know that the distance is a positive 6. All right? Okay, so then I'm going to say, so then this length here, this distance here between those 2 points then will be, use Pythagorean theorem. So then I'm going to say c squared will equal 4 squared plus 6 squared, right? And then let me go ahead and do that here. So c squared then will be 4 squared, which is 16, 6 squared, which is 36. And so c squared then will be 16 plus 36. If you use your calculator, 16 plus 36 gives me 52. And so to get c by itself, I'm going to take the square root of both sides. So c will be the square root of 52. And then you would simplify this. But let's go ahead and leave it like that for right now. So there's your length. So your distance is the square root of 52. Okay? So notice I use Pythagorean theorem. Now I'm going to come back to this in a little while. But we use Pythagorean theorem to do this. And if you want to go ahead and simplify this, you can. Let's see. Besides the number 1, 4 is a perfect square that goes into 52. You get 13. So this will be the square root of 4 times the square root of 13. So you get 2 square root of 13. So there's your distance. So this distance here is 2 square root of 13. Okay, now we're going to use this idea to derive the formula. Okay? So first of all, do you understand that I took at some point I took the square root, right? So you see the square root? And at some point, what did I do to those x coordinates right here? I subtracted, correct? Did I subtract those? Yes. And then once I subtracted those, what did I do to this number 4? I squared it. Do you see a square right here? Yes. All right. So you notice that here, you see all those similarities in here. Okay? All right. So let me go ahead and derive it, though. So to derive it, I'm going to go ahead and use an xy plane that's not numbered. Okay, that's not numbered. And I'm going to go ahead and call, if this is x1 and this is y1, then this point is the point x1, y1, right? If this is x2 and this is y2, then this point here is x2, y2, okay? And what I want to do is find the distance between those 2 points. That's what I want to do. So just like I did here, just like I did this, I'm going to go ahead and draw a right triangle. So I'm going to go ahead and draw a right triangle, just like this. And remember, once we drew that right triangle, the next thing I did was I asked you what was the coordinates of this point. Well, it's 5, 2. Y'all agree? So I'm going to ask you, what are the coordinates of this point? Well, it's x2, what else? y1. x2, y1. Okay? All right. Now, the next thing we did was we found those horizontal distance and we found the vertical distance. So we found the length of this leg and we found the length of this leg. Since that's a horizontal distance, we just subtracted the x coordinates. Okay? So let's do that here. So what are the x coordinates to find this distance? I subtract the x coordinates. So I'm going to put an absolute value though. So I'm going to say x2 minus x1. All agree? Okay. Because remember, if I go one way, it's negative. If I go the other way, it's positive. But remember, distance is always positive, so I always take the absolute value. Over here, what did I do? I subtracted which coordinates? I subtracted the y coordinates. So what are the y coordinates here? y2 minus y1. Still absolute value. Because remember, it's got to be positive. So if I say y2 minus y1 minus y2, that could be that's going to be negative. So I need to make sure I have absolute value there. Okay. All right. Now, once I found the 4 and the 6, I use Pythagorean theorem. So I'm going to call this D. So here's what we have. According to Pythagorean theorem, according to Pythagorean's theorem, I have this. I have d squared equals each leg squared. Now, since I'm squaring, I don't need absolute values anymore because I'm going to be squaring it. It's going to be positive anyway. So I'm going to have x2 minus x1 squared. So that's this leg squared. Plus, and then this leg squared, y2 minus y1 squared. And then how do you get d by itself? You take the square root of both sides. And so the distance between these 2 points is this. The square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? And so that is the derivation of the distance formula. Okay? All right, so let's go ahead and do some problems with this. So this is going to be number 1. So number 1, let's suppose we had, now the direction is going to say, find the distance between each pair of points, simplify the radicals when possible, and then round to 2 decimal places. Okay? All right, now, do not use Pythagorean theorem. Well, in other words, I don't want you to go in and plotting those points and using Pythagorean theorem. I want you to use the distance formula. So you use the distance formula. All right, so remember the distance formula is this. The square root of, you subtract your x coordinates from each other, you square it. Subtract the y coordinates from each other, and you square it. Okay? And then you add them up, and then you simplify. That's all you do. So if I look at number 1, we have negative 7, 1, and negative 8, 2. Now it helps, it really does, it helps if you label these. So I'm going to call this x1, y1. And my second point, I'm going to call it x2, y2. Now, remember when we talked about the derivation here, we said someone could have said 1 minus 5. 1 minus 5, that would have been a negative 4, but you know the distance has to be positive, so that's why we needed absolute value. Okay? So the order that you did this did not matter as long as you took absolute value. So what I'm saying here is this. You see how I have x2 minus x1? Someone else could say x1 minus x2. It does not matter because you're squaring it. Okay, so in other words, someone else could have said this. Someone else could have said, well, could I subtract x1, could I say x1 minus x2? Yeah, because you're squaring it, and whatever it is going to be positive anyway, right? Plus, and then you could do the same thing here, y1 minus y2 squared. Does not matter. Does not matter in which order you subtract, because you're squaring it. All right, so you can say negative 7 minus a negative 8, or you can say negative 8 minus a negative 7. Does not matter. Does not matter at all. But since the formula is there, most students prefer to go ahead and label these first and then just plug in what they see. Okay, so let's go ahead and do that. So the distance will be the square root of, you got to make sure you say square root. You got to write it just like I have it. Okay, so in parentheses, x2. x2 is a negative 8, right? Subtract x1, which is a negative 7. Whatever that is, I'm going to square. Okay? Plus, then I'm going to say parentheses y2, which is 2. Subtract y1, which is 1. Whatever that is, I'm going to square. All right? Now again, make sure you say square root. Equal square root. Now let's go ahead and simplify this. Do y'all agree that negative 8 subtracted negative 7 means negative 8 plus 7? Okay. And do y'all agree that 2 subtract 1 means 1? I'm going to square that. And let's go ahead a little bit further. What's negative 8 plus 7? Well, that's a negative 1, right? So that's negative 1 squared plus 1 squared. What's a negative 1 squared? Make sure you have that in parentheses. Because if you don't put that in parentheses and you use your calculator, it's going to say negative 1. But that's supposed to be a positive 1, because the negative 1 times itself is a positive 1. In fact, whenever you square these numbers, it should always be positive. Or 0. But it's never negative. So basically, this is never negative. Never negative. It's always positive or 0. Okay, so that'll be the square root of 1 plus 1. Now you got to remember your grouping symbol is a square root, so you got to do this radicand first. 1 plus 1 is 2, so I get the square root of 2. And can I simplify the square root of 2? No. So the distance will be the square root of 2, and then they ask you to approximate this. So you're going to say distance is approximately equal to, and it says 2 decimal places. So on your calculator, say square root, then press 2, press equal. You get 2 decimal places, 1.41. 1.41. So remember, 2 decimal places means the hundredths place. So you got to look at the thousandths. Since that's the thousandths place is less than 5, then that one's going to stay 1. All right, number 2. So you see, it's just plug and chug. That's all you're doing. So it's not difficult. All right, number 2, we have this. We have these 2 points. So we have -4, -3, and the other point is 6, 1. So label x1, y1, x2, y2. And then you just plug into your formula. So distance equals the square root of, and remember, always say this, always say, I'm going to subtract the x coordinates from each other, whatever that is, I square it. The order in which you subtract does not matter because you're squaring it. So if someone does 6 minus a -4, that's positive. If someone does -4 minus 6, that's negative. It doesn't matter because you're squaring it, and it's going to be 100 anyway, right? Okay, so it doesn't matter. Plus, and then y2 minus y1 squared. Okay, don't forget the square root. All of that's under that square root symbol, so don't forget the square root symbol. That's important. See all these steps? You must show all these steps. You must show square root, square root, square root, square root. Okay? All right, so plug and chug. So the square root of, parentheses, x2, which is 6, subtract a -4, right? Whatever that is, I'm going to square it, plus, and then parentheses, y2, which is 1, subtract a -3, whatever that is, I'm going to square it. Okay? All right, let's go ahead and simplify the radicand. Square root of 6 subtract a -4 means 6 plus 4 squared, plus 1 subtract a -3 means 1 plus 3 squared. And so let's go ahead and simplify this a little bit further. 6 plus 4 is 10, so I get 10 squared. 1 plus 3 is 4, so I get 4 squared. So then this becomes the square root of 10 squared is 100, right? Plus, and then 4 squared is 16. Now be careful, don't make the mistake and say the square root of 100 plus the square root of 16. So that's not true. That's not the square root of 100 plus the square root of 16. That's not true, okay? So don't say that that's the square root of 100 is 10, the square root of 16 4. Don't say that's 14. That's not 14. Because look, if I do the square root of 116, 100 plus 16, the square root of 116 is not 14, right? It's 10.770 and so on. Okay? All right, so be careful. Some students do that. They make a mistake and they say, oh, I know the square root of 100. I know the square root of 16, so that's just 14. It's not. It's not. You have to think of the square root as a grouping symbol, so you got to do what's under the radicand first, and then take the square root. So this is the square root of 116. Okay? All right. Now, you need to simplify this, because remember the direction said simplify the radicals if possible. All right, so let's look at 116. Besides 1, the next perfect square is 4, so let's see if 4 goes into 116 evenly. 116 divided by 4, and it does, and 29 is a prime number, so that's good. So this becomes the square root of 4 times the square root of 29. And then the square root of 4 is 2, so you get 2 square root of 29. Okay? All right, so that's the distance. So the distance is 2 square root of 29. Remember, it said simplify the radicals, so you got to make sure you do that. It also asks you to approximate, so the approximation symbol. And you want to approximate to 2 decimal places. Now, okay, listen carefully. You see this right here? You could have messed up here, right? You could have messed this thing up. This is correct, and you could have messed this up. So what I would do to approximate is I would go here. I would approximate this. All right, so you're going to say the square root, 116, equal, and then 10.77, 2 decimal places. Then what I would do is I would say, all right, I'm not sure if this is correct. So let me go ahead and approximate this and make sure I get the same thing. See that? So let's see. So I get 2 times the square root of 29, press equal, and you get the same thing. So what I have here is correct. Okay? All right, so that was number 2. Number 3. So let's suppose in number 3 we have this. So here's number 3. So number 3, you have these 2 points. We'll go ahead and rewrite those. So -1, -1, and -6, -7. Okay? And so I want to find the distance between those 2 points. Now remember, I do not go into the coordinate plane and label those points -1, -1, which is here, okay, and then -6, -7, which is here, and then draw your line, or your segment rather, and then use Pythagorean Theorem. That's not what they want you to do, okay? But you're interested in finding this distance. So the question is, what is this distance? But they want you to use the distance formula. So use the distance formula. Okay, use the distance formula. Okay, so let's call this x1, y1, and this will be x2, y2. Okay, and so the distance then would be the square root of, parentheses, x2 minus x1. So you subtract your x coordinates. Always say this to yourself, I need to subtract the x coordinates from each other. Okay, so x2 minus x1, so -6, subtract -1 squared. And whatever it is, I squared. So remember, you subtract. Okay, so you subtract these 2 x coordinates. See that? So I'm subtracting those 2 x coordinates. Plus, and then I do the same thing with the y's. I subtract the y coordinates. So -7, subtract this y coordinate, which is -1. And whatever that is, I'm going to square. So you see, you're subtracting your x coordinates, you're subtracting your y coordinates. Now let's go ahead and simplify the radicand. So this becomes the square root of, so notice the square root symbol, -6 subtract -1. That means -6 plus 1 squared, plus -7 subtract the -1 means -7 plus 1 squared. Okay, so then that becomes -6 plus 1 is a -5, so that's a -5 squared, plus -7 plus 1 is a -6, so that's a -6 squared. And then we go ahead a little bit further. -5 times itself is 25, so you get the square root of 25, plus -6 times a -6 is 36. Add them up, and we got to add them up. So you're going to say 25 plus 36 is 61. Okay, and the square root is 61. Now, 61 is a prime number, so you're done. So the distance is the square root of 61. Now let's go ahead and approximate this. So that's going to be approximately equal to, so the square root of, square root of 61, okay, let me do it over, square root 61 equal 7.81, so that's approximately equal to 7.81, okay? So basically what you found is that the length, the distance between this point and that point is approximately equal to 7.81, and it's exactly equal to the square root of 61. That's what you found, okay? Number 4. So number 4, you have these 2 points right here. So we have -4, -7, and -1, -1. Okay? All right. So then we have, let's label these x1, y1, x2, y2. Okay? So then I get distance is the square root of, remember you subtract your x coordinates, the order does not matter. Most people want to start with x2, so you say -1 subtract -4. So -1 subtract -4, whatever that is there, though, you got to remember to square it. So just think Pythagorean Theorem. The leg squared plus each leg squared. So this leg squared plus this leg squared. Okay, think it like that. Plus, And then I got to subtract the y coordinate. So negative 1 subtract a negative 7 squared, right? Okay. Equal square root of, now let's deal with the first parentheses. So negative 1 subtract negative 5 means negative 1, I'm sorry, negative 1 subtract negative 4 means negative 1 plus 4 squared. Plus negative 1 subtract negative 7 means negative 1 plus 7 squared. Okay? Now let's simplify this further. Negative 1 plus 4 is 3, so I get 3 squared, plus negative 1 plus 7 is 6, I get 6 squared. So this becomes the square root of, don't forget square root, 3 squared is 9, 6 squared is 36. And then 36 plus 9 will give me, what's that, 45? Okay, square root of 45. All right, now you got to ask yourself, though, can I simplify the square root of 45? Yes, because what perfect square goes into 45? 9. So that's 9 to square root of 9 to square root of 5, right? So the distance will be 3 to square root of 5. So there's your distance simplified. So that's what you would put. So in your answer, you would say distance equals 3 to square root of 5. All right, so you remember you got to simplify your radical. Now let's go ahead and approximate. So we're going to approximate 2 decimal places. Now again, just like we talked about before, you could have easily messed this up. So let's go ahead and use this one. So the square root of 45, the square root of 45 is 6.71, right? Since that's bigger than 5 or bigger, then the 0 becomes 1. 6.71. Now let's see if what I have is correct. So 3 square root of 5. So let's see, 3 times square root of 5, press equal, 6.71. So this is correct. All right, so that's number 4. Okay, number 5, we have this. All right, number 5, you have the point 0, negative square root of 5, and the other point is square root of 7, 0. Okay, just because there's some square roots here, don't make that don't let that scare you off. Just go ahead and use the formula: x1, y1, x2, y2. Okay, let's see what happens. So the distance is the square root of, remember you subtract your x coordinates, so the square root of 7 subtract 0, right? And whatever it is, I square it, plus, and then I subtract the y coordinates. 0 subtract a negative square root of 5. And I square it, correct? 0 subtract a negative square root of 5. Just make sure you're writing this correct. Okay, equal. All right, square root of 7 minus 0 is just square root of 7. So the square root of 7, but I got to square that, plus. Now, do y'all agree that 0 subtract a negative square root of 5 is a positive square root of 5? 0 plus square root of 5? So that's just square root of 5 squared. Okay? Don't forget the square root symbol. All right, and you're adding these two. Okay? Equal. All right, let's think about this. Just like we did in the previous problem, right here, 3 squared means 3 times 3, right? 6 squared means 6 times 6. So do y'all agree that the square root of 7 squared means the square root of 7 times the square root of 7, which is the square root of 49, which is what? 7. So that's just 7. Plus, the square root of 5 squared means the square root of 5 times the square root of 5, which is the square root of 25, which is just what? 5. So that's 7 plus 5, square root. And what's 7 plus 5? Well, 7 plus 5 is 12, so that's the square root of 12. Now, can I simplify the square root of 12? Yes. What perfect square goes into 12? 4. So it'll be the square root of 4 to the square root of 3, so that's 2 square root of 3. So the distance is 2 square root of 3. Okay, so that'll be your answer. Now they want you to approximate this. So let's go ahead and approximate the square root of 12, and we'll approximate this as well. So the square root of 12 is 3.46. So let's see if this is the same thing. So 2 times the square root of 3, 3.46. Okay? All right, so that's number 5. Let's look at number 6. Number 6, you have these points. 4 square root of 3, comma, square root of 5, and negative square root of 3, comma, 3 square root of 5. All right, again, don't let the square roots throw you off. You can do this. It's not difficult. It's just using a formula. That's all it is. So let's again label these. It helps if you label these. Okay, so x1, y1, and then my second point, this will be x2, y2. And then just using a formula. So remember, distance is the square root of, you subtract your x coordinates from each other. Does not matter in the order you subtract because you're squaring it. And do the same thing here. Subtract your y coordinates from each other, but you got to remember to square it. All right, so let's plug these values into here. So I get distance is the square root of, parentheses, x2, which is negative square root of 3. I am subtracting. Remember, you always subtract. So you got to say subtract x1, which is 4 square root of 3. Whatever that is, though, I've got to square it. So don't forget to say that. Plus, don't forget the plus symbol, parentheses, y2, which is 3 square root of 5. I got to subtract, so you got to say subtract, y1, which is the square root of 5. Whatever that is, though, whatever that difference is, I've got to square it. Okay? So the first step is to make sure you write all this in correctly. All right, now you got to ask yourself, what's a negative square root of 3 and a negative 4 square root of 3? Do y'all agree that's going to be, don't forget the square root, do y'all agree that's going to be a negative 5 square root of 3? Because a negative 1 square root of 3 and a negative 4 square root of 3 is a negative 5 square root of 3. And then you square it. Plus, what's 3 square root of 5 subtract square root of 5? Well, that is 2 square root of 5. And whatever it is, I square it. All right, now, the next step, you can do it just like you did this one. So remember, the square root of 7 squared means the square root of 7 square root of 7. Okay, we did all that work here. Do the same thing. Okay, so watch how simple this is. Let's do this one first. 2 square root of 5 times 2 square root of 5. Okay, now remember, you're multiplying, so the order in which you multiply does not matter. So do y'all agree that 2 times 2 is 4? So I get 2 times 2, and then say square root of 5 and square root of 5. All right, so 2 times 2 is 4, and then the square root of 5 times square root of 5 is the square root of 25. And what's the square root of 25? Well, that's just 5, right? So that's 4 times 5, which is 20. So this right here is 20. Okay? So 2 times 2 is 4. Square root of 5 and square root of 5 is 5. So 4 times 5 is 20. Let's do this one now. So here you have a negative 5 square root of 3 times a negative 5 square root of 3. All agree? All right. What's a negative 5 times a negative 5? Well, positive 25. What's a square root of 3 times the square root of 3? All right, in your mind. Now, most of you know it's 3, right? But if you didn't, you'd say the square root of 3 times the square root of 3 is the square root of 9, which is what? 3. It's just your radicand. And what's 25 times 3? 27. I'm sorry, 75. All right, so 25 times 3 is 75. So this becomes the square root of 75 plus, and that was what, 20? Okay, so this becomes the square root of 95. Y'all agree? Okay, now let's see if there's a perfect square that goes into 95. Well, first of all, I know it's divisible by 5. I know that 5 is not a perfect square, but I'm just going to go ahead and use it just to help me. So 95 divided by 5 is 19, and 19 is prime, so the only perfect square that goes into 95 is 1, so I'm done. So your answer, the answer here, you're going to say the distance is the square root of 95, okay, and approximation, so the square root of 95 gives me 9.75, right? Since that's 5 or bigger, this becomes 5. So 9.75. All right? Okay. Now, some of you may need to go back and review this little part here, though. Okay? So be careful. So make sure you understand how this became 75. Make sure you understand how this became 20. All right? Okay, let's do one more. So this will be number 7. Now, number 7 is going to be a fraction. And don't let it throw you off. The fractions here are not that bad. So 7, we have the point negative 3/5, comma, 4/7. And the other point is 7/5, comma, negative 10/7. All right, again, they're not that bad because notice that the x coordinates, they both have the same denominator. The y coordinates have the same denominator, okay? So the distance, let's label these x1, y1, x2, y2. So the distance is the square root of, and let's go ahead and write down the formula. So remember, you subtract the x coordinates from each other. Does not matter the order. So someone else could have said x1 minus x2. Does not matter because you're squaring it. So it's always going to be positive or 0, never negative. And then y2 minus y1 squared. Okay? All right, so let's plug in 2 here. So I get the square root of x2, put parentheses, don't forget parentheses. So that's 7/5, subtract a negative 3/5, right? Okay, whatever that is, you're going to square though. Okay, keep that in mind. So make sure you say that. Make sure you write it just like this. Plus, parentheses, y2, which is negative 10/7, subtract y1, which is 4/7, right? Extend that radical, so make sure you say square root. All that's under that square root symbol, and don't forget to square right here. Now we're going to simplify this. What is 7/5 subtract a negative 3/5? Do y'all agree that you're going to change subtraction to addition? So that's add the opposite. So it becomes 7/5 plus 3/5. And what's 7/5 plus 3/5? Well, that's 10/5, right? Which is what? 2. So this becomes the square root of 2 squared. Okay? So make sure you understand how this right here became 2. All right? Plus, now let's do this one. What is negative 10/7 subtract 4/7? Well, do y'all agree? The way I would do this is I would change it to an addition problem. Do y'all agree that becomes negative 10/7 plus a negative 4/7, right? So I'm adding two numbers whose signs are the same. So what's a negative 10/7 plus a negative 4/7? Well, that's a negative 14/7, which is what? Negative 2. So make sure you understand how this right here became negative 2. But don't forget you got to square that, so make sure those are all in parentheses. Now what is 2 squared? Well, that's 4. What's a negative 2 squared? That's 4 as well. What's 4 plus 4? Well, that is 8. Can I simplify the square root of 8? Yes. What perfect square goes in a 8? 4. So that becomes 4. Oops, sorry. That becomes the square root of 4 and the square root of 2, right? And what's the square root of 4? Well, that's 2. So there's your distance. So the answer, the distance is 2 square root of 2. Now let's go ahead and approximate this. So the approximation symbol. Let's use the square root of 8. So the square root of 8 is, the square root of 8 is 2.83, right? 2.83. Now let's use this. So 2 times the square root of 2 equal 2.83. Okay? All right, so that is the lesson on finding the distance between 2 points. Okay? And again, make sure you know how to simplify. So some of you may need to go back and kind of review those square roots right here. So make sure you go back and do that if you need to. All right, so that takes care of this lesson.